Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of cross product. So as per the problem, for the vectors p, q and r, show the following to be true. So let's start with part A. The vector p cross q cross r can be written as a linear combination of vectors p and q. So let's start by finding the cross product of P and Q. So for that, we should stack the y, z, x and y components of vectors P and Q. So for vector P, the y component is -2, z component is 3, x component is 1, and y component is -2. For vector Q, the y component is 1, z component is 3, x component is 2, and y component is 1. Now we can find the x, y, and z components of the cross product of vectors p and q. So let's start with the x component. So we do -2 times 3 minus 1 times 3. I get x equals -9. Now we can find the y component. So we do 3 times 2 minus 3 times 1. So we cross multiply the z and x component. So I get y equals 3. Now we can find the z component. So we should cross multiply the x and y components. We do 1 times 1 minus 2 times -2. So I get z equals 5. The cross product of these vectors is now we have to find the cross product of this vector and vector r. So we should stack the y, z, x and y components of these two vectors. So for this vector, we just found the y component is 3, z component is 5, x component is -9, and y component is 3. And for the r vector, the y component is 1, z component is 0, x component is 1, and y component is 1. Now we can find the x, y, and z components of the cross product. So let's start with the x component. So we should cross multiply the y and z components. So 3 times 0 minus 1 times 5. So I get x equals -5. Now we can find the y component. We should cross multiply the z and x components. 5 times 1 minus 0 times -9. So I get y equals 5. Now we can find the z component, and for that we should cross multiply the x and y components. So we start with negative 9 times 1 minus 1 times 3. I get z equals negative 12. So the cross product of these two vectors is vector negative 5, 5, negative 12. Now we have to show that this vector can be written as a linear combination of vectors P and Q. So we'll have to write the linear combination equation. So we're using the scalar A for vector P and scalar B for vector Q. So we have to find the values of A and B that satisfy this vector equation. So the first step is to multiply the components of vector P by A and components of vector Q by B. Now we can add the vectors on the right side. We can add their x, y, and z components. These two vectors are equal to each other if their x, y, and z components are equal to each other. So we can write three equations for A and B. We can simplify this third equation by dividing each term by 3. So these are the three equations we have to use to find out whether the cross product can be written as a linear combination of vectors P and Q. We'll use two of these three equations to find the value of A and B. So we can use the first equation and this last equation. We can solve for B from these two equations by subtracting the two equations. We are using the elimination method. Negative 5 minus negative 4 is equal to negative 1. The A terms will get cancelled out. And 2b minus b is b. So that means the value of b is negative 1. Now we can sub in this value of b in either of the two equations we use to get this value of b to find the value of a. So we can use the second equation. We can isolate a by adding 1 to both sides. So a is equal to negative 3. Now we have to check whether these a and b values satisfy this third equation that we got from our vector equation. And if they satisfy this equation, that means the cross product can be written as a linear combination of P and Q. So we'll sub in A as -3 and B as -1 in this equation. So it's this one. Now we have to simplify the right side. So the left side is equal to the right side. That means we have proved that the cross product of P and Q and R can be written as a linear combination of vectors P and Q. So we are done with part A. Now we can analyze part B. In part B, we have to prove that P cross Q cross R is equal to P dot R times vector Q minus Q dot R times vector P. We have already found the cross product of vectors P, Q and R, which is vector -5, 5, -12. So we have to analyze the right side of the equation in part B. So we'll start by finding the dot product of vectors P and R. The vector P is 1, -2, 3. Now we can do the dot product. So we should multiply the x, y and z components of these two vectors. So 1 times 1 is 1, -2 times 1 is -2, and 3 times 0 is 0. So I get -1. Now we can find the dot product of vectors Q and R. So we can multiply the x, y and z components. 2 times 1 is 2, 1 times 1 is 1, and 3 times 0 is 0, which is equal to 3. So this is the dot product of vectors Q and R. Now we can multiply the dot product of P and R by vector Q minus the dot product of vectors Q and R, which is 3 times vector P. Now we can simplify this vector expression. So we'll multiply the vector 2, 1, 3 by -1. So we'll multiply all three components by -1. And we'll multiply the other vector 1, -2, 3 by 3. Now we can subtract these two vectors by subtracting their x, y and z components. So -2 minus 3 is equal to -5. -1 minus -6 is equal to +5. And -3 minus 9 is equal to -12. This vector is equal to the vector we got from the cross product of vectors P, Q and R. So that means the vector equation given in part B is true. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it and subscribe to Homework Help. Thank you very much and have a nice day. Bye.